So we now know what test we need to use based off the previous video. I told you it's a Wilcoxon signed rank test that we're going to use. Now, bizarrely, in JASP, it's actually presented under the t-test option. And to do that, we need to actually select the paired samples t-test option, which is the test I told you that we weren't going to use, but it falls under that umbrella term of tests there. So we're going to select this option. And what we're going to need to do is we're going to need to select the two pairs of variables that we're interested in, so a healthy and unhealthy condition. And we're going to move this over into the variables box here. So we can see that a table's been populated. It's provided us with the test, the paired samples t-test, which is a test I told you that we can't use because our data doesn't meet the assumptions needed for that particular test. So what we're going to do is we're going to navigate over to this area here. We're not going to select the student option. We're going to unselect that because we said that's not an appropriate one to use. And instead, we're going to select the Wilcoxon signed rank test. So we've selected that option now. We can see our table's been updated. But there's one other thing that we need to do here as well before we can start looking at our table. We also need to look at the alternative hypothesis. And we need to remember whether or not we determined that a one-tailed hypothesis was appropriate or a two-tailed hypothesis. Now, JASP by default selects the option two-tailed. And if you remember, we actually said, do you know what? We've got enough evidence here based on previous literature to suggest that a one-tailed hypothesis would be appropriate. And as such, what we're going to do is we're going to select the second option here. And the reason we're going to select this second option here is because we've got a one-tailed hypothesis. But more specifically, our one-tailed hypothesis suggested that the healthy condition would receive higher ratings than the unhealthy condition. And I can tell that's what that information or that option's telling me. So if I look over at this table here, it tells me that measure 1 represents a healthy condition, measure 2 represents the unhealthy condition. And what this symbol means over here in the alternative hypothesis box, that's a greater than symbol. So saying measure 1 will receive a higher rating than measure 2, which is precisely what we predicted. And once we select that box, we can then start to have a look at our table over here, where it tells us whether or not we've got any statistically significant findings between the two conditions. And what it reveals to us if we navigate to the p-value over here is that the p-value is below the threshold of 0.05, which means that we've got a statistically significant difference. In this case, it's quite a bit below 0.05. In fact, it's smaller than 0.001. So this test, the Wilcoxon signed rank test, tells us that there's a statistically significant difference between the healthy condition and the unhealthy condition. And as a visual reminder to make sure that we know which way it differs, we can select the descriptive plots options over here. And what it'll do is provide us with a graphic representation of the differences between the two conditions. So on the x-axis here, it's got healthy condition and unhealthy condition. On the y-axis, it's got the rating. And what we can see here in the healthy condition, participants provided higher ratings than they did in the unhealthy condition. So we can visually see that and go, yes, I can see what's happened. The healthy condition has received higher ratings than the unhealthy condition, which is excellent news because that means that we've replicated the attribute conditioning effect that's been reported in the literature within our paradigm, which is a new experiment, a novel online experiment that's been created by myself, and we've been able to see the power of attribute conditioning there. We've got a statistically significant difference. Now, the way in which we would write that up, we need to report that p-value, and also we need to report the figure, the number represented under the W sign there. I'm going to include some text on the Canvas page, which will tell you about how you need to report that test. So it'll say this is the type of information that you need to report when you're reporting a Wilcoxon signed rank test. It's also good practice, and I think it would certainly be a lovely addition to your report to include a graphic visual which highlights the difference between the two conditions. But unfortunately, the JASP image that has been provided here, the sort of default setting, isn't one which would typically be used for this type of experiment. And it also isn't meeting the APA standard that we'd like to see when reporting a visual or a graph. So we're actually going to have a look at using Excel in order to create an APA suitable graph. And I'm going to give you some hints and tips so that you can make an appropriate graph for your science report there as well, so you can see how to do that. I'm a big fan of Excel, so hopefully you will be too, and we'll have a look at how to create a lovely APA visual in the next video.